Honda eHEV versus Toyota eCVT versus 300,000 miles. Hybrid battery life, planetary gears, series parallel architecture, reliability, long-term ownership. This is where it actually matters. Because you've probably heard some version of this. Toyota hybrids will run forever. Honda finally nailed it with eHEV. Both are Japanese, both are hybrids, just pick the one you like. Meanwhile, if you plan to keep a car until the odometer starts looking like a phone number, 200,000, 250,000, maybe 300,000 miles, that lazy thinking will cost you. These two systems are not the same. They don't age the same, and one of them has way more proof behind all the bulletproof stories. I'm GearHead. I care a lot less about brand wars and a lot more about what's actually happening inside the metal, under hydrodynamic lubrication, at high coolant temps, under repeated cold start wear, and after 15 years of real-world abuse. If that's how you want to think about hybrids before you buy one, make sure you're subscribed, because this is exactly the kind of choice that quietly decides whether you're still driving the same car at 300,000 miles or complaining online at 140,000. Let's break down Honda eHEV versus Toyota's eCVT the way your dealer never will. How they work, how they're stressed, what's already gone wrong in the real world, and which one I'd personally bet on to survive 300,000 miles. First, how they actually work, because hybrid is not one thing. On the surface, Honda eHEV and Toyota's eCVT both look like full hybrids. Gasoline engine, plus electric motors, plus a battery, plus clever control software. But under the hood, the architectures are very different. Let's start with Toyota's eCVT, also known as Hybrid Synergy Drive. This is what you'll find in the Prius, Camry Hybrid, RAV4 Hybrid, Highlander Hybrid, Lexus RX Hybrids, ES and GS Hybrids, and more. Inside the transaxle, you've got a gasoline engine, usually Atkinson-cycle. You have MG1, which is a motor and generator. You have MG2, the main drive and generator. You also have a planetary gear set, which is the power split device. And finally, reduction gears and a differential to the wheels. Here is a very simplified power flow. The engine, MG1 and MG2, are all mechanically linked via the planetary gear set. MG1 can start the engine and generate electricity. MG2 actually helps drive the wheels and recovers energy under braking. By controlling the speeds of MG1 and MG2, the system changes the relationship between engine RPM and road speed. There are no belts, no cone pulleys, no squeeze the belt harder like a conventional CVT. From the driver's seat, it feels like a CVT because engine revs can sit constant while road speed changes, but mechanically it's a fixed set of gears plus electric machines. Now for Honda eHEV. You'll see this in the Accord Hybrid, CR-V Hybrid, the latest generation Civic Hybrid, the Jazz and Fit Hybrid, the HR-V Hybrid, and related models. The layout consists of a 2-liter or similar Atkinson-cycle engine, a generator motor, a drive motor, and a single fixed ratio gear and clutch to mechanically link the engine to the wheels at certain speeds. Most of the time, at low to medium speeds, the power flow goes from the engine to the generator, which makes electricity, which goes to the drive motor, and finally to the wheels. That's basically a series hybrid. At higher, steady speeds, a clutch engages a direct link between the engine and wheels through a fixed gear. The engine now drives the car mechanically with the drive motor assisting as needed. So, to summarize the differences, Toyota uses a power split parallel hybrid where the engine is always tied into the gears when it's running. Honda uses a series dominant hybrid that becomes direct drive at cruising speeds. Why does that matter for 300,000 miles? Because how torque and RPM are handled through the system decides where wear shows up. Now, let's look at the track record. Who's actually done 300,000 miles? If we're asking which system actually lasts 300,000 miles, the first thing you look for is evidence. For Toyota's eCVT, it has been in service since the late 90s, with the first-generation Prius in Japan in 1997. It has been refined through multiple generations, from the Prius to the Camry to Lexus SUVs to the RAV4 and Highlander and so on. There are millions of these vehicles worldwide. Real-world examples include Prius taxis with 300,000 to 500,000 kilometers, or 180,000 to over 300,000 miles on their original transaxles. There are Camry Hybrids in taxi and rideshare fleets doing 200,000 to 250,000 miles on their original hybrid gearboxes. And there are Lexus RX 400h and 450h where the rest of the vehicle gets tired before the eCVT does. When these do die, it's usually because of engine issues on specific generations, hybrid battery aging, which is often past 10 to 15 years, rust and chassis wear, and cooling neglect. The transaxle itself rarely shows up as the failure headline. Now for Honda eHEV. Honda has a long history with hybrids, but not all of it is good. Early IMA systems, or integrated motor assist systems in the Civic and Insight, had real battery durability issues and were less robust overall. The eHEV, which is the two-motor series with direct drive system, is far newer. It has been available in volume from the mid-2010s onward and is present in the current Accord, CR-V, Jazz, and Civic hybrids. So far, it is generally very reliable. There has been no global wave of motor or clutch failures, and no "they all die at 100,000 miles" pattern. But you don't yet see hundreds of thousands of eHEV cars at 250,000 to 300,000 miles. The data simply isn't as deep yet. So on pure longevity proven so far, Toyota's system has a 20-plus year head start with tons of high-mileage examples. That doesn't mean Honda can't match it or beat it, it just means the proof isn't as strong yet. Let's talk about design stress. Where are the stress points over 300,000 miles? For the Toyota eCVT stress map, the mechanical core consists of the planetary gearset, MG1 and MG2, and the reduction gear and differential to the wheels. Its strengths are that it uses all fixed gears, has no belt and no multi-gear clutch packs shifting under load. Smooth power delivery equals low shock loads, and conservative tuning means the components are under-stressed. Its weak points over extreme mileage include overheating from cooling system neglect, either in the engine or inverter loop, running ancient burnt transaxle fluid forever, and contamination from catastrophic engine failures where metal circulates in the case. Most of that is abuse or neglect, not the design can't take it. For the Honda eHEV stress map, the mechanical core includes the drive motor, which does most of the wheel turning in the city, the generator motor, which spins whenever the engine is on in series mode, the clutch and fixed gear link for direct drive, and the engine, which sometimes runs as a generator and sometimes as a direct prime mover.
Long-term stress points include the drive motor bearings and thermal load because it does a lot of work. The generator motor is the same story but with more stable RPM. The direct drive clutch engages and disengages at highway speeds, and clutches can wear or glaze if heat or calibration is off. Finally, the fixed gear mesh for direct drive must handle constant torque at speed. Still, Honda knows how to build engines and gearboxes. The eHEV has been praised for its refinement and so far has not been plagued with horror stories. But it's a more complex blend of modes between series and direct connect. There's more switching between paths. Over 300,000 miles, every time you add complexity and mode switching, you add places for odd wear patterns to show up. Toyota's strength is brutal simplicity. One planetary gear set, two motors, no shifting, just power splitting. Honda's strength is clever efficiency and a very EV-like feel. The engine mostly just feeds the motor or locks in for the highway. From a fewest moving parts perspective, Toyota's architecture has fewer stressed mechanical interfaces. What about engine life at 300,000 miles? Whose gas engine is happier? You can't get to 300,000 miles if the engine doesn't also play along. Toyota hybrid engines are often Atkinson-cycle, especially the 1.8-liter and 2.5-liter. They have lower peak torque and cylinder pressures. They're heavily assisted by the electric motor at low speeds, and they spend a lot of their time in efficient load and RPM bands. Common weak points include the Generation 3 Prius 1.8-liter, which can suffer from EGR clogs and head gasket problems if neglected. There can be oil consumption if intervals are stretched forever or the wrong oil is used, and cooling system neglect can lead to overheating and head issues. But in well-maintained cars, the 1.8-liter and 2.5-liter Atkinson engines routinely hit 200,000 to 300,000 miles without rods coming through the block. For Honda eHEV engines, you have 2-liter Atkinson or similar engines in the Accords and CR-Vs. They're very efficient, often running in optimal efficiency zones in series mode. On the highway, in direct drive, they behave like a simple engine with a fixed-gear drive. Weak points known so far are not many yet. Honda's typical vulnerabilities still apply, like oil neglect leading to VTEC and filtering issues or chain and tensioner wear, and cooling neglect bringing a head gasket risk, but nothing hybrid-specific has emerged as a major failure vector at scale so far. If I had to bet on the pure longevity of just the internal combustion engine portion, both are solid if maintained. Toyota's hybrid engines have a longer high-mileage track record in hybrid duty. Honda's Atkinson eHEV engines look promising but are still newer data. Let's look at battery and inverter life. Who handles electrons better long-term? Both systems rely on medium voltage packs and power electronics like inverters and DC to DC converters. Toyota used nickel metal hydride in many older models and lithium-ion in newer ones. Their notable strengths include a conservative state of charge window, robust cooling with dedicated fans and ducts, and ridiculously long-lived nickel metal hydride packs in many cases, often lasting 10 to 15 plus years. A weak point is cooling fan and intake neglect. Pet hair and dust clogging can cook packs early. And age. Eventually, cells drift and capacity drops. But again, there are huge numbers of Toyota hybrids still on their original packs after well over a decade. For Honda eHEV, they use lithium-ion packs in most modern implementations. This is better chemistry than the old IMA days, with better management and cooling than before. The track record so far shows no obvious mass failure trend like early Honda IMA systems had, but there are not enough 15-year-old eHEV packs yet to fully match Toyota's time in the field. As for inverters, Toyota had some early Prius inverter recalls, especially around Gen 2 and early Gen 3. Those got fixed and updated, and later systems are robust. Honda inverters in the eHEV show no widespread pattern of failures yet, but again, they are newer. If you forced me to choose for a 300,000-mile aim, I'd give Toyota a slight edge, simply because they've been doing hybrid battery management longer and more conservatively in more markets. So, if you want to own one hybrid from 0 to 300,000 miles, who wins? From a pure highest probability of hitting 300,000 miles with minimal drama in 2026, Toyota's eCVT hybrid system is the safer bet. Why? Because it's mechanically simpler in the transaxle. It has a staggering real-world track record at high mileage. Its common failure modes are well understood and avoidable, like cooling, EGR, and battery fan cleanliness. And taxis and fleets around the world have already proved it in truly abusive conditions. Honda's eHEV is genuinely clever and refined. It is likely very durable to 150,000 to 200,000 plus miles, and probably capable of 300,000 in many cases, but we just don't have the same depth of data yet. That doesn't mean don't buy eHEV. It means if your personality is, I want the safest possible long-term bet, a Toyota hybrid with an eCVT is like buying the index fund of hybrid drivetrains. If you like how the Accord or CR-V hybrid drives, prefer Honda's steering and chassis feel, plan to keep it 8 to 10 years instead of 20, and you're okay being a little earlier on the curve, the eHEV is a totally reasonable choice with a lot of upside. Just don't let anyone tell you that all Japanese hybrids are basically the same, or Toyota's eCVT is just a CVT, avoid it, or even Honda eHEV is unproven junk, because that's not fair either. You're choosing between a proven conservative planetary gear-based system that already has 300,000-mile trophies on the wall and a newer, more EV-like series dominant system that looks good so far but hasn't had as long to show its scars. If this helped you see past the brand noise and actually understand what you're betting on with each system, make sure you're subscribed. Next, I'm going to do something a lot of people avoid. Walk through what you actually check on a used Toyota Hybrid versus a used Honda Hybrid if your goal is 200,000 plus more miles, including which noises, scan data, and service records matter and which are just seller fluff. I'm GearHead. Every hybrid system has a story, and together we're going to decode which ones you can realistically trust all the way to 300,000 miles.